Okay, so welcome everybody. My name is Giorgio Marfella and I'm the chair of the Architects Registration Board of Victoria. So welcome for the first webinar of the 25-26 series of the Architects Registration Board CPD. As always, I'd like to begin by acknowledging the traditional owners of the land, of the many lands in which we are meeting today. And in particular, I'm in the land of the Wurundjeri people of the Kulin Nation, and I pay my respect to the elders, past and present. So today we have a technical webinar like we had before, and we understand that they are fairly popular. And we have a guest who is Dr. Tim Lowe from RIC Solutions, and Tim is the head of building science at RIC Solutions, and he's going to take us through some issues concerning condensation in particular, and how there are, of course, regulatory implications both in the NCC as well as some new Australian standard provisions. And before I'll hand over to Tim, I'd just like to remind everybody that this is a CPD opportunity for formal CPD points according to the framework that we administer at the ARBV. CPD, of course, as you all know, or at least all the architects who know, is mandatory in Victoria. And you will see that there is a form that you can fill in with some questions to provide evidence of attendance. Now, contrary to previous practice, this time we will let you fill the questionnaire after the presentation. You'll have 24 hours to complete that. So in other words, we will not stop along the way to fill in some questions. We have a lot of content. And as always, towards the end, time permitting, we might go through with some final questions to wrap up. So with this, I can simply hand over to our guest, Tim, and over to you.
Thanks, Giorgio, and welcome everybody. Thank you for having me here. We've got quite a lot to cover, so I'll be speaking fairly quickly, but I would love to have some form of interaction with you. I understand all you can send over to me are some emojis, but that will be good enough. At least it prevents me from being the only one laughing at my own jokes. Right, so let's make a start. A bit about myself. I'm an architectural scientist, and I will talk a bit more about what architectural science is. I did this in the University of Tasmania, and then I was the chair for building surveying at Victoria University. Currently, I'm working at RIC Solutions, but I'm also have an adjunct research position at the University of Melbourne. The photographs here just show you the kind of things that I like to do. I like to get my hands dirty. And I think that is that side of architecture that I really love, because you've got to understand how buildings fail in order to make them high performance. Very quickly, something about architectural science, in case you think I am making up a term that doesn't exist. This is a uniquely Australian term. It came from the time of Zockerley and Cohen, where they looked at the concept of using passive solar as a way of doing bioclimatic design. And it involves many aspects. Currently, it is quite broad. It involves aspects of computing and parametric design and so forth. I'm not so much involved in there. I'm still quite old school. I'm looking at very much the building physics, but really extending that to the biology of microbes and occupants. So this is where we publish in, it is a fairly high-ranked journal, the Architectural Science Review. Some of the articles are open access, but that is where you find the main outlet of our journal publication. Now let's talk about, let's get this out of our system, talk about architectural documentation, because this comes up ever so often. This came up recently in the ARBV webinar with Steve Bexus, the state building surveyor. And he expresses his sadness that standards are diminishing, and he doesn't blame the architects. This is really an industry-wide problem. The issue is that poor design, and I think poor design means different things to different people. To an architect, a poor design is a design that's not well resolved. But to anyone outside the industry, poor design is anything that lacks design documentation. And that's what they're referring to, that there is the adequacy of design documentation has been really a subject of industry scrutiny, with findings suggesting that there's a link between poor design documentation and project variations, increased cost construction, and potential construction and non-compliance of building works. So it's not just non-compliant documentation, it's insufficient documentation. When the VBA, currently the BPC, did some audits, this is looking at class 2 to 9 buildings, they listed the areas in which there was insufficient information, looking at the dark blue bar. And you find that is most predominantly in the area of weatherproofing. The same audit was done, once again, looking at building surveyors' permit drawings and seeing whether there was sufficient documentation on them, this time in class 1 buildings, and some multidisciplinary audits, and they found in this case the light blues are those with insufficient information, and you find that all those that tend to relate to moisture problems, of which condensation management is one of them, tend to be the ones that lack sufficient documentation. In this report by the Architects Registration Board of Victoria and New South Wales, there was, in one of the appendices, a rather candid admission that under documentation of standard essential details and design documentation may be a form of risk avoidance for architects. I think it could be the case because sometimes, let's say you do a bathroom and you say fall, but you're not sure, was it 1:80 or 1:100? It's 1:100 currently, but in NCC 2025, whenever that is implemented, it's going to be 1:80, and you're not so sure about that. There might be a way of saying that, how about I don't put it down, just so that I won't be wrong about it. So that's what I think they mean by avoiding that risk as a result of and adopting under documentation as a mechanism for that. To properly understand the whole scope of this, I thought I should give you a timeline of how all these condensation management provisions came to be. It started in 2012 when I was at the University of Tasmania. A rather distraught builder came to us architectural scientists asking for help. He says that the ceiling of his newly built house has just collapsed. And when we looked at this straight away, we could tell it was a condensation problem. It's been something that we've been dealing with since we introduced 6 stars into the NCC, and we've been noticing a lot of condensation problems, but this photograph was the one that was really quite graphic. We took it to the building regulator. The building regulator then set aside money for us to do some research on this, on which we developed the Tasmanian Designer's Guide for Condensation in Buildings. So this is what it looks like in that guide, basically looking at how we deal with introducing ventilation pathways into roofs and walls, especially in the light of bushfire requirements like AS 3959. Following up on this, and it was the Tasmanian Building Regulators' credit that they were banging on tables for a very long time, that the ABCB finally funded a study. You might have been part of that survey. We had about 2,000 respondents answering those questions about what did they estimate the frequency of condensation problems to be in brand new class 1 and class 2 buildings. You will see that climate zone 7 is quite overrepresented here because Tasmania was overrepresented in the survey responses. But across the board, regardless of climate zone, regardless of states, we found that the general estimate was that 1 in 3 buildings had condensation problems. That is just condensation. We're not even adding things like damp proofing, weatherproofing, and waterproofing, all the other things that create mold and other issues. 2018 was quite a big year in that one of the federal members for Parliament, Lucy Wicks, was a champion because she suffered from a mold illness. She pushed very hard for the health minister to look into this with more seriousness. So there was a federal parliamentary inquiry into this thing called biotoxin-related illness, or loosely spoken, mold illness. And there are a couple of recommendations, one of which applies already to us, that they were asking for the adequacy of codes to be reviewed, whether we have proper prevention and remediation of dampness and mold in buildings. 2019 was a big year. Finally, for the first time, we had condensation management provisions in the NCC. In 2019 also, Tasmania had its own variation, its own DTS pathway, which referenced the designer's guide, which in this case was the updated version 2 of the one that we did a few years before. 2019 also introduced a verification method, which was quite broad in that if you looked at all those things, it could be an acceptable verification method to meet the performance requirements. I looked at those verification methods and I looked out there, and there wasn't something that worked natively with NetHERS files. So I thought I would write a software code because I knew the science behind the building physics part, and I knew a little bit about programming to be able to put them together. So I started writing a software for that. The idea was basically to take the engine. The engine in NetHERS is called the CHINF engine. So taking that CHINF engine, but replacing the weather file with something that is more representative of a stress test using real weather instead of a reference meteorological year or RMY weather file. Taking the temperature profile, putting a condensation analysis on top of that. And what I found in the process was that I've created an engine with no inputs. We had no weather files and we had no material files. So all we had was an engine with no wheels and no chassis, no nothing else. So I left it aside. And to my surprise, in NCC 2022, we introduced DA07, which was the new verification method. And then hydrothermal analysis became the big thing. It was the basis on which we updated the NCC 2022 condensation requirements to include the other climate zones. That was the big thing recently also, that the study by University of Wollongong was used as the basis for NCC 2025. I've been banging on ABCB saying that you can't keep changing the code based on simulations. We need real world data, because otherwise it is really a situation of garbage in, garbage out. You don't have the right inputs. We are taking weather files from who knows where, and we're taking material inputs from who knows where, and we're just changing the code based on that. So I think in order to just shut me up, they've recently launched this approach to market to look at physical testing. This is the first time we are doing physical testing around condensation management, and I'm really stoked and looking forward to the results of that. Right, now coming to the performance requirements, this we can talk about for 1 hour. It will surprise you, but this one little statement: risks associated with water vapor and condensation must be managed to minimize the impact on the health of occupants, can actually be part of a 1 hour entire presentation. Let me break it down a little bit. If we were to look at this and we put it on the side, and being architects and visual thinkers, I'd like you to think about this as a conceptual map. We start with a central concept. We pick up what is the one key word in this entire statement on which everything is connected to as secondary concepts. So we have a central key concept and we've got associated concepts. These associations have got to be made by a connecting word. Usually I'll pause for you to respond, but you can't respond, so I'm just going to proceed on this. The key concept in my mind is risk. Risk from something to something for which something must be done to it. The risk is from water vapor or condensation. Now, this is a big deal. For us, we don't think so much about water vapor because we have a condensation risk that's quite eminent. But in the subtropical and tropical climates, it is no longer just about condensation, but dealing with high humidity, because water vapor now is the risk factor more so than condensation. So what is the risk from this to? Well, the risk is to the health of occupants. So what must be done to this risk? So the risk must be managed to minimize the impact on the health of occupants. Now you see how this whole thing forms a conceptual map and a kind of a loop. Now, what does it mean to manage the risk? We have some guidance in the Guide to the NCC, and this was in 2019, where the estimate is that every person gives off about 10 liters of vapor per person per day. That is your cooking, breathing, showers, everything put together, and that is 10 liters per person a day. If I manage that and I made it 5 liters per day, have I managed the risk of condensation? Theoretically, I have. I have reduced that risk, well, by 50%. But have I minimized that risk to the impact on health? Now, that is a different question. 10 liters of vapor per day would produce mold. 5 liters of vapor per day will also produce mold. So I haven't quite managed the risk to minimize the impact on health. Do you realize how broad this thing is and how we are suddenly pushed away from our familiar domain of the built environment to something that we are not so familiar with, and that is health. We are looking now at biological systems. Let me put this in a way that we can compare. Let's look at two performance requirements, one for rising damp and one for condensation management. We start off with the subject, right? One is looking at moisture, the other one is looking at vapor and condensation. One is looking at a requirement. One is prevented, the other one is managed. Straight off, you see they are very, very different. Prevention has got a very clear threshold. If moisture penetrates, you have not prevented it. Here we are looking at management. Management is not the same as prevention. I do a little bit to manage, I have managed it. The question is whether I have managed it sufficiently. Now, we are looking at the controls. One is in terms of prevent something from causing something. The other one is to manage something to minimize the impact. In terms of damp, we're looking at dampness, deterioration, unhealthy or dangerous what? We're looking at building elements or conditions, but condensation is looking at the health of occupants. So we're moving away from building elements and conditions, things that we used to be familiar with, things that we could control, into something that we are totally unfamiliar, the health of occupants. And so this is where I think architectural science is so much more than building physics. It also involves understanding a bit of microbiology to understand how mold germinates, grows, and proliferates, and also to know how things like mold and other microbes like bacteria, how do this impact the health of occupants? So we're looking at microbiological and macrobiological systems. So it's more than just physics, it's also biology. Now, we can go on this for a long time, but in the interest of time, I'm just going to drill down into a few things that I'm afraid sometimes we might miss. And the first one is this thing called pliable building membranes. Now, the term pliable building membranes is a defined term, but defined according to who? Now, this is a very useful resource. If you haven't used it yet, this is a construction dictionary, .com.au, that basically pulls out all definitions across the NCC standards and everything. So if you put in pliable building membrane, it comes up with a few answers. One of them is from AS4200, which talks about a material that is able to be folded back on itself without causing structural damage. So that was how pretty much all of Australia understood pliable building membranes until NCC 2019 redefined that. It redefined that as a water barrier as classed in AS4200 Part 1. So no longer is it just a membrane that can be folded back on itself, but a membrane that was classed as a water barrier. What is the class of a water barrier? It must pass the test specified in AS/NZS 4201 Part 4. Now, if you take a look at this, the test is a test to hold a head of water 100 millimeters high for 24 hours. And it begins to beg the question, why do you need that in a wall that has got a drainage cavity? In what world would you need a membrane that can hold a column of water 100 millimeters high in a wall? Probably for a roof, that might make sense, but for a wall, why? But that aside, the NCC definitions overrides the AS4200 definitions. Now, in this case, we're talking about in NCC 2019, a pliable building membrane, if it's installed in an external wall, it must comply with this. Now, what are possible membranes? One of them is foil, but foil in itself is not a vapor permeable membrane. That's why we use it to wrap chips, right? We package chips inside and it doesn't get soggy. But we can make it vapor permeable if you punch holes in that, right? So in this case, a micro perforated kind of a foil. But this foil will no longer be a water barrier. And so foils are actually not pliable building membranes. Surprise, surprise. It's really bizarre, but this has created a different world for us. We are only allowed then to use plastic membranes such as those made from polyolefin, polypropylene, or polyethylene. Well, they're actually all pretty much the same thing. Polyolefin is a chemical category that includes things like polyolefin and as well polyethylene and polypropylene. But the important thing is that polyolefins are petrochemical products. They are flammable. They burn with a very hot and clean flame accompanied by melting and dripping like a candle, something like that. Now, you don't really need us to burn plastic for you to see that, but this was just done for visual theatrics to just modify the AS1530 Part 3 test to show that these membranes are not suitable in a condition that has a flame. But we are allowed to use these membranes under a special concession. The concession is that sucking type materials that do not exceed 1 mil in thickness and have a flammability index not greater than 5. Now, this is under the context of external walls, under the context of a concession for AS1530 Part 1 non-combustible. Non-combustible and flammable are actually different concepts. What is this test like? This test is basically you clamp a membrane over a flame, you light the flame, you see how high up it goes. But in the scope, very importantly, it says the test is unsuitable for materials which melt readily or shrink away from an igniting flame. meaning you can't use this test on plastic membranes. You see, what happens is that when you put this on a plastic membrane and the membrane melts before it catches fire, it doesn't catch fire. And because it doesn't catch fire, it appears to be non-flammable, not because it is non-flammable, but because it has melted away from the flame and is no longer touching the flame. So this is an example of what it looks like. This is a full-scale facade test, fiber cement on the outside, metal cavity barriers, and then you've got a fiber building membrane of plastic that goes through. What we see here, what we just saw here was that the fiber cement after a while popped out. But when they looked at this forensically after the fire, they found that that membrane, that combustible sacking became the wick to bypass those cavity barriers. So it passed through all compartmentation inside that drainage cavity. So to think about it, we have been dealing with the issue of combustible cladding, but we have taken the plastic out of the combustible cladding and put that plastic into the membrane, unencapsulated inside a drainage cavity that can potentially catch fire and bypass all compartmentation. I put some thought into this, and before the days of AI, this is as close as I can get to poetry. Let me read it to you. To illustrate the difference between code and legislation, we turn to the then latest version of NCC 2019 with the newly introduced section, Condensation Management. One of the requirements was that all buildings in climate zone 6, 7, and 8 are to have vapor permeable membranes. Vapor permeable sackings are permitted to be used where non-combustible building elements are required if they do not exceed 1 mil in thickness and have a flammability index not greater than 5. The flammability test, AS 1530 Part 2, is much less rigorous and only requires a flame source in unspecified room conditions as opposed to a furnace setup in a fire testing facility for the non-combustibility test, 1530 Part 1. Furthermore, the applicability of this test is questionable for vapor permeable membranes because the test is unsuitable for materials which melt readily or shrink away from an igniting flame. Now, what are these vapor permeable membranes made from? From the data sheet of main Australian manufacturers, they are listed as polypropylene and polyethylene or polyolefin. Note that polyolefin is the chemical category which includes polymers such as polyethylene and polypropylene. Importantly, unless treated with chemical fire retardants, all polyolefins are combustible and burn with hot flames. To summarize, by way of application, the NCC now requires that in places such as Melbourne Climate Zone 6, the walls must be wrapped with vapor permeable membranes. That is, sacking that is exempt from a non-combustibility test and adopting a flammability test method that is ill-suited to plastics made from the same material found in the course of combustible cladding that the Victorian government is spending $600 million to replace. Simply put, should vapor permeable membranes be installed in walls that were intended to be non-combustible in terms of NCC compliance? Yes. In terms of public safety, no. Now, there has been a change. We have moved from NCC 2019, where we had the clause titled Pliable Building Membrane, to NCC 2022, where we no longer use that as the heading of the clause. We now call it external wall construction. And note here in subclause 2, where a pliable building membrane, sacking type material, blah, blah, blah. So now you can use perforated foils. And if you are not doing that, what are you exposing yourself to by moving, by creating the very same risks that we had with combustible cladding by specifying combustible sacking? So basically, we have this 3 conditions. It's got to be non-combustible, a water barrier, and vapor permeable. When I published, I couldn't find a product with all 3. I believe there is now one product that has all 3, but I won't tell you which one it is. Now, the other thing that I think might be of interest to you is the verification method, because quite often you might find that your creativity might go beyond what the DTS pathway allows you to do. Now, I'm just going to forewarn you that the verification method is actually harder than it seems. To understand this, we've got to understand climate files. I'll start with what we are most familiar with, and that is the NatHERS files, called the RMY, or Reference Meteorological Years. So what you do with an RMY is that you look at your past history of record and you work out this thing called the Finkelstein-Schaefer statistic. Basically, you're trying to find the most middle of the road month of January in your record, and you stitch that with the most middle of the road February, average March, average April, and so forth, and you stitch it all into 1 year, and that becomes your RMY. We can take RMY and add in the precipitation because energy files didn't need rain. To comply with the DA7 approach, you have to have rain inside there. So what UTAS did was basically a bridging approach to introduce rain data. Let's say it was January 1995. I look up the weather station, I pull up the rainfall, and now we have an RMY plus precipitation, which is currently what we have in WUFI 7 that was just given to us this year. So basically, before this year, WUFI did not have any Australian climate files. Every hydrothermal simulator had to create their own files. What happens is that if you look at RMY, in this case, I'm pulling out a case from one of my projects, looking at Cairns, the blue spikes show you where the minimum temperature goes below dew point. So that's a condensation risk. The pink lines basically show where we have continuous period of high humidity of more than 48 hours. Two pink lines indicate that we have 2 days of that threshold being breached for 48 hours. So looking at the blue and looking at the pink lines, you basically get a feel that, well, that's roughly the kind of risks we are looking based on RMY. Now, if I were to put in real data from BOM, you'll find that the blue peaks are a lot more frequent and a lot higher. The pink lines are a lot denser and across the year. The thing is that RMY being the average of average is not suitable for a hydrothermal stress test. It is suitable for an energy test because you don't want a year that's too hot or too cold. You want middle of the line to basically estimate what kind of energy you use, because if you get that wrong, what is the big deal? You just pay more bills, right? But if we get our hydrothermal simulation wrong, and then we get mold, we create a health risk, and the health risk makes the building uninhabitable, and we fail in our task of providing proper dwelling for people. So then we need a very different criteria when it comes to doing a hydrothermal analysis. We find that the best practice is to use this thing called MRY. Now, I know the acronyms are driving you crazy, but bear me on this. MRY is the moisture reference year. It is based on basically looking at 30 years of data. Each year, we work out a moisture index, which is your wetting index less your drying index, and that is your moisture index. We put it up, and then we basically sort them. 1 to 30, 1 being the worst year, 30 being the least bad year, and we pick number 3. That is the top 10th percentile. So not the worst of a cyclone year, but basically a reasonably bad situation. And we use that as a simulation for doing the mould index calculation. And the University of Sydney has been fantastic. They have made this publicly available for 30 of the most common towns across Australia. There is yet another year. It is called the MDRY, Moisture Design Reference Year. It is not quite an MRY. We are using, once again, a 10th percentile, but a 10th percentile is not based on a moisture index. It is based on the 10th percentile warmest and 10th percentile coldest year. Now, before you tell me to look up the reference, I did. And the reference doesn't say anything about how to do this method. So I summarize it here. DA07's MDRY definition based on temperature lacks a viable path for practical implementation. We don't know how to create the warmest or coldest year. Are you looking at average, maximum, minimum? Is it aggregated daily, monthly, annually? Are we having heating or cooling degree days? Is it seasonal weighted? We have no method. Then we cannot actually produce what is this MDRY. And even if MDRY could be operationalized, why are you looking at the warmest and coldest without any humidity and rain data? Why are we using that as our criteria? In fact, ASHRAE, which also produced ASHRAE 160, on which DA07 was based on, ASHRAE themselves have abandoned this method. Currently, the gold standard is MRY, not MDRY. And if we use what we have currently that's built in, that is NatHERS RMY plus precipitation, those are average years. They are not the 10th percentiles. So we have created a definition that cannot be complied with. And we only have 2 ways of compliance with the weather input. Read here. The analysis shall be performed using a minimum of 10 consecutive years of weather data, or using the moisture design reference year weather data. So I went down this track, and it felt like I went down a rabbit hole on a wild goose chase looking for a unicorn. Did I just put 3 animals together? But basically, I found that I had to try so hard in order to find that I couldn't comply even if I wanted. The only way to comply is 10 consecutive years. Thank God, University of Sydney also gives us that, but this is a much smaller data set, only a few capital cities. You have that for Melbourne and nowhere else. So if you're outside of Melbourne or in a climate that is significantly different, you're on your own. You've got to look for a 10-year weather file somewhere, somehow, with precipitation data in order for you to have a DA07 compliant VM pathway. Now, in the time we have, I've talked so quickly, I can actually talk more slowly from now onwards. Let's talk more slowly about this. And because I think this is an important and complex matter, the architect's duty of care. Let us start from this. If you're not already aware, the rental minimum standards have been stepped up since 2021. Each room in the rented premises must be free from mold and damp caused by or related to the building structure. So if a person is in a rental premises and they find mold, the first question they've got to ask is that, is this caused by the building structure? Is it related to that? If it is an urgent repair. And until that is fixed, the tenant can even make the case that it is unfit for habitation because it doesn't meet the rental minimum standard. Now, this is big because that becomes part of your problem. If the client said, this is an investment property, I'm building with the purpose of renting. And what if you create mold as a result of a condensation mismanagement? You see how the rental regulations have gone way past where the NCC is. They're looking at real-world outcomes while we are still talking about hydrothermal simulations. And we found that the insurers have wised up to this also. They have already started putting mold exclusions on top of combustible cladding exclusions. Now, I'd like to bring up where we are in terms of the restoration industry, which is where I work with a lot nowadays. In the restoration industry, for example, if you find a building has got flood, there is a professional standard in terms of how you do the cleanup. If you find that you have got mold other than a flood, there is also another standard how we can go about that. One of these has already been adopted as an Australian standard, AS-IICRC S500, the standard for professional water damage restoration. S520 for professional mold remediation is in the process. Within a matter of weeks, we should see this become an Australian standard. So just take it for now that these two are Australian standards. S500 explains the health link. So now we cannot say there is no standard that makes the health link between microbial contamination and the health of occupants. The list is as 4 categories: inflammatory, allergenic, infectious, and toxic. And the state moisture accumulation leading to a state of unabated dampness resulting in the growth and amplification of molds that can damage valuable materials and adversely affect human health. Now we have the link that brings us back to the performance requirement for condensation management that asks us to manage the risk in relation to the health of occupants. We need to minimize that risk. S520 puts the spotlight in a few areas. The building inspections, when an indoor environmental professional goes to assess these buildings, is to look for a few things, including condensation. So as our work becomes up for scrutiny post-construction, these issues would come back and you'll follow the chain up to the builder, to the RBS, the relevant building surveyor, and also to the designer. I'd like to show you a few materials that are really what mold thrives on. Here is a case of plasterboard. This is not condensation related. It was an escape of liquid, but you see the idea that it grows more on that plasterboard than pretty much any other material. Mold just love plasterboard. You see, the purpose of fungi is to break down cellulose-based material. But if you have turned cellulose-based materials like trees into pulp, you are pre-digesting the material, so the mold doesn't even have to work very hard to extract those nutrients. This you can tell is a condensation issue because it's coming top down from the roof. You can see the lines that mark up either the trusses or the battens. So we can tell that this is a top down, this is condensation related. Plasterboard, really not a good material where condensation risks are high. Now, how about using plasterboard to do a pelmet where you run the air conditioning? Cold air inside, warm air outside. What do you get? You get condensation on that, and you get growth on those plasterboard pelmets that are used for HVAC supplies or returns. Now, this one is a really big problem. Fire compartmentation, those fire-rated walls. The nature of this fire-rated walls is that they have got to be built together with the walls, which creates two problems. One is that it is not roofed over during the construction process. And the second one is that if you were to pick certain materials such as shaft liner, because of the way it slots into the edge joists, these materials cannot be replaced. So we are stuck with a situation that these things are prone to exposure to the weather. And once they are moldy, we actually have no way of replacing them as the Australian standards for S520 require. So we are stuck in this regulatory no man's land. This is an example of basically a subfloor that is way too wet. You can see mushrooms and other fungi growing there. And this happens when you got a slope site. It doesn't matter which way the slope is going. One of the walls is going to be an external wall to an uphill slope. And there should have been a cutoff drain so that the water doesn't accumulate in the subfloor. And that is a design decision. There should have been a cutoff drain, and there wasn't in this case. And quite often you end up putting planters on the outside, and as the owner puts more and more mulch on those planters, eventually they block those ventilation holes, and that's what happened here. But you notice that there's some mold growing on the test oak, but it is way, way more significant on the yellow tongue particle board flooring. The particle board flooring was never intended for a place that was constantly exposed to high moisture. Once again, particle board is mold food that is pre-digested. So we are creating the nutrients for the mold to grow. This is fiber cement sheeting flooring, FC sheet flooring. What is the fiber in fiber cement? It once upon a time was asbestos. When asbestos was outlawed, we replaced that with cellulose fibers. There's actually more cellulose in 1 square meter of FC sheet than there is in 1 square meter of plasterboard. So if you leave this constantly in a damp environment, the underside of this became so wet that mold started to grow on FC sheet. It even grows on unused FC sheet that was left in the weather for too long. Coming back to the Act, we would think that the Act protects the health of people, especially when that is the first stated objective of the Act. And we find the only implementation of this in this section on 106, where the RBS has the prerogative to exercise the opinion. My opinion doesn't matter. The RBS is the only one entitled to the opinion if the building is a danger to the health of any member of the public. Now, I was the course chair for the only place in Victoria where you could get the prerequisite qualification for an unlimited building surveyor. And I know our curriculum doesn't cover the health consequences of building permits. So this is a no man's land. I don't think many RBSs are comfortable working out a determination or expressing even an opinion that the building is a danger to the health of somebody. So basically, this section never gets exercised. And they will also make this claim that under Section 24, the RBS must not impose lesser or greater standards than required by those prescribed by the Act. So to them, the building surveyor's duty of care is to ensure compliance. But what is the architect's duty of care? And now again, we have this particular document. There is a common law duty of care. And what is the flip side of that? That is a failure to discharge is deemed as negligence, and you become open to those kind of complaints or lawsuits. Now, what happens is that these services are very broad. Let me give you an example. What is a wet area? It is bathrooms and laundries. Is a kitchen a wet area? Not in the NCC. So the RBS cannot insist that you turn the kitchen into a wet area. But the architect, if so inclined, you can exceed those requirements based on a duty of care to cause no harm. This is what it is. When a project has an inherent element of risk, the architect has an obligation to at least warn the client of that risk. And it goes on. It is not just to the client, but any third party that relies on those documentation. And one of the biggest complaints received by ARBV includes cases where they do not have the skills to or experience to know whether or when to engage other specialists. So here there are some other resources that I'd like to recommend to you. The VBA, now BPC, publish this regulatory priority. You find that water is now even a high priority compared to fire safety. I think they have dealt with the fire safety for a bit. They're turning their attention to water. In the area of water, I was surprised that I was mentioned a couple of times because I feel that this should be a much wider case and there should be more research done in this area. But the two publications mentioned here are these two. One is a scoping study on the nature and extent of moisture damage in houses and apartments in Victoria. There was some when I was at VU, and the other one done when I was in Brick Solutions currently, moisture-related building disputes. Now, if I'm just going to pick up a one-paragraph summary, and I'm not going to make any friends after this, is that for this report, I said, the design aesthetic of contemporary dwellings featuring articulated cubes and projected planes compromise a building's first line of defense to water ingress, that is to be able to deflect water in a traditional design. Planning requirements have introduced building elements such as balconies, which result in geometric complexities. Design aspirations may be exceeding the designer's technical abilities to design watertight buildings, and poor design documentation has resulted in non-compliance and poor quality that compromised the watertightness of buildings. And in the next report, I said, design decisions have consequences that appear in the case studies to be largely neglected by a lack of construction details and written specifications. Typical details in the waterproofing standards do not encompass all possibilities and require adaptation by the design practitioners to incorporate unique considerations for each application. You might be aware that quite recently we had this big discussion about the Buyer Protections Bill, now passed into law, but this is the ability of the BPC to issue rectification order as one of the key instruments. This is in relation to building work that is incomplete, non-compliant, or is defective up to 10 years. Now, the term defective is pretty broad, and it doesn't just encompass the workmanship of the work, but also can be attributable to defective design, right? That's where we come in. And where this has caused the building to be uninhabitable, pointing back to the rental minimum standards. If there's mold, it is not fit to be rented out. That gives any complainant very strong case to say that even if it is not for rental, if there is mold, the building is uninhabitable and unable to be used for its intended purpose. I tried to respond to this, and to put a long story short, it is well intended, but poorly executed. The long version is in this book. I wanted to show where the loopholes were, so I created basically a form of Trojan horse advocacy, and I wrote this book called The Defect Evasion Playbook. I'm basically channeling the voice of a disreputable builder, an old one, teaching the young builder how to find loopholes in the law. So it'll be something like that. Should some impudent owner, emboldened by a TikTok video or a neighbor's tale, dare to utter the words defective or not in a workmanlike manner, you must treat this as a personal affront to your very throne. You must play the deeply offended professional. Draw yourself up to your full height. Let your voice quiver with righteous indignation and begin your demands. That is your opening position. Take umbrage. How dare they question your sovereign authority? Demand, demand, demand. It is the first step to a prosperous and untroubled reign. The strategic brilliance of demand is this immediate reversal of roles. The complainant arrives believing themselves the injured party, only to leave feeling they have somehow wronged you. They came seeking redress. They leave seeking forgiveness. Remember, dear Shonki, in the game, he who demands, commands. I somehow find Dodgy's voice a very straightforward way of putting forward and framing the issues. So I'm going to channel that voice once again to address a few questions from let's say, a nephew that is an architect and asking him for advice around condensation. Can't the architect simply say that we have the problem even though we just simply design to the code? Dodgy would answer, you architects love referencing the NCC. Maybe a bullet point on moisture management, a note about ventilation as required, and then a flourish of glass, ply, and hope. But here's the truth. The code's requirements for condensation are just enough to fend off an auditor, not enough to fend off physics. Nearly every audit, ARBV report, and government research paper, and there have been many, says the same. Plans are invariably thin, documentation's perfunctory, and the attitude is She'll be right, mate. We all know it. But now, so do the regulators. And worse, so do the judges. To the question, Uncle Dodgy, so many other architects are under-documenting. It isn't just me. It's been an industry sport. Leave the plans vague, lean on standard practice, let the builder fill in the gaps, and if trouble comes, point the finger at everyone else. Builders, surveyors, or the poor sort who lived in the place and had the temerity to hang a towel indoors. Sadly, those old moves aren't landing anymore. Why not? Because everyone in the know, tribunals, insurance investigators, even the VBA, now draws a straight, soggy line from under-documentation to defects. When condensation, mold, or rot turns up, the court won't ask about your signature vision. They'll ask what you did to manage foreseeable risks. Because by now, the risk is as well known as the price of smashed avocado in Fitzroy. But Uncle Dodgy, if all designers under-documented, surely that should be the norm, the normal expectation from the profession. Back in my day, common industry practice was a decent shield. All the architects do it was good for a laugh, and sometimes it worked. But when the risk becomes common knowledge, that argument becomes a rope to hang you. Everyone's doing it wrong. The court says, terrific. Now everyone's liable, and you just got picked first. No matter how much you plead the poverty of fees, the squeeze of disinterested client, or the industry standard of mediocrity, a professional's duty is to act as a professional. If you know the materials will absorb moisture like a sponge in a brewery, and you do, and if your plans weigh vaguely at managed condensation according to the NCC, then you haven't done enough. Uncle Dodgy, good thing we're in Victoria and not New South Wales. Now let me pour vinegar in the wound. Over the border in New South Wales, they've wised up. The DPPA has made it law that architects must assess, document, and declare their designs comply with every requirement, sustainability and moisture. They register, they submit compliance declarations, and they are liable directly, not just in theory, but in cold hard cash, for economic loss caused by defective design or under-documented buildings. No hiding behind the builder, no industry practice, no, but the plans were vague excuses. Expect those regulations to land in Victoria sooner rather than later. The days of plausible deniability, vague notes, and shifting responsibility are numbered. What's compliance in Sydney is about to become mandatory in Melbourne. With the BPC stepping up, not just as referee, but as a rule maker, if they haven't started, they soon will. Document boldly and decently, because what's enforceable up north will soon be enforceable here. So to summarize, and this part is important because it comes up in the quiz, what is the way we can outflank condensation complaints before it even starts? First, warn. Warn the client in writing about what is foreseeable, that mold food like radiata pine, engineered timber, including LVL, particle board, plywood, OSB, etc., and especially paper face plasterboard, these things all hate condensation and moisture as much as a pensioner hates a cold call from the tax office. If your budget doesn't stretch to best practice solutions, say it. Get the owner's signature. Don't let them say you left them in the dark. Next, build your file, not just your building. What you knew, what you told, how you handled it. When the tribunal asks, show that you thought, not just followed. Finally, if you're following the pack, remember, the pack might be heading over the cliff. First over isn't lucky, and the others aren't far behind. I hope this has been helpful to you and that you learned some new things. I hope it hasn't been too late and you have already made some mistakes and committed to them. But I am reasonably active on LinkedIn. I publish quite often. There are a few chapters from the defect evasion playbook. Also, some of the things that I mentioned here, I published before on things like what is a pliable building membrane, fiber cement sheets, and so forth. So probably the best thing, or the best place for us to stay in touch is through LinkedIn. And I would welcome any questions. And thank you very much for your time.
Thank you, Tim. I think you're receiving a standing ovation at the very least this time. But before I'll touch on some questions. I don't think we'll have time to go through all of them. But also in response to some comments, yes, this will be provided as a recording, like always. So we always leave a recording available for 24 hours for you to complete a questionnaire and submit evidence of participation. But also after that, if you visit the ARBV website, you'll find we have a track record of webinars we've been now doing for more than a year. So And in this instance, you might want to play at a half speed. I think I would recommend, because Tim speaks quite fast. We had a lot of content, as you saw. So I'll go through some questions. Now, you did mention the fact that there is a product that is apparently compliant. Now, no, we're a bit.
Yeah.
Are you
Yeah.
comfortable to indicate at least what it might?
I could point you in the right direction. I'm not completely convinced it is a 1530 Part 1 compliant, because 1530 Part 1 requires the testing of the system. So this is the technical specifications. It is a fiberglass product on which a Teflon coat has been applied. The fiberglass allows it to be 1530 Part 1. The Teflon allows it to allow vapor to pass through whilst meeting AS4204, that is the water barrier test. I'm not sure it is the right approach, because I would have thought you should put the complete product into the furnace. So I can't endorse it, but I could point you in the direction. It is a TBA Firefly product.
Okay. I think that will certainly give some indication. And you have given everybody your contact through LinkedIn, so you might get some questions directly after this, I suppose.
By all means.
It is our preference not to recommend specific products, as you can understand. Now, there's some questions concerning, I suppose, the issue of different methods that results, of course, in mold issues. And now the first one talks about membranes in roofs, and especially in very flat roofs. Is there anything you would like to add on that? Is that a particular area that might lead to condensation problems?
Okay, I'll answer this into two parts. Let's look first at a metal roof. And there are systems that deal with that. The broad system is known as warm roof. Basically, you're trying to keep the underside of your roof warm by some means, rather than allowing it to get cold, because once it gets cold, it drips condensation. So even if you have got a water barrier underneath it, that water barrier gets cold because water is going to pond there, and the underside will get cold. Always look at the underside of a cold surface. Think about it, that if you're trying to thaw frozen chicken in a sink, and you put a frozen chicken in a sink, you fill it with water, the whole sink gets cold and the underside gets wet. Not because it is leaking, but because of condensation. So the underside of the roof is going to get wet, so we can't allow it to drip down. So the idea is that to keep it warm, and there are systems that deal with that. Anti-con or permastop is one of the ways of dealing with them, but it in itself is not complete. The reason is, once you screw down on a roofing blanket, you squish away the fiberglass blanket, and therefore you lose pretty much all the R value. On those parts, especially if you've got metal battens, you would get very little R value. The metal battens would get cold, and you get condensation on the metal battens, and the metal battens become a gutter to lead the condensation somewhere else, you don't know where. So where you're getting the water dripping down from is not the same place as where the water emerged from. So you can't just use that. So you end up, if you really wanted to look at another system that creates a thermal break, right? If you're looking at a CSR system, it's called ash grid. So the ash grid system creates a thermal break in the insulation blanket, so that you don't squish down the insulation blanket. Now that is looking at a flat roof, metal roof. The other one that is completely omitted in the NCC is a balcony. If you had a balcony over a habitable space, and that sometimes comes as a requirement of you having to step your facade backwards due to the issue of planning requirements, because of sight lines, because of overhanging, because of solar access. Sometimes your balconies get stepped as you go upwards. When you do that, your balcony is over somebody else's living area. Warm underneath, cold above. That is the one we have basically no mechanism of dealing with for the time being. Because what you have is that to make the balcony waterproof, you apply a waterproofing membrane. The waterproofing membrane was never designed to be vapor permeable. Not after you put in an adhesive mortar bed and the tiles. But the whole system makes it basically vapor impermeable. You got a vapor impermeable cold roof and a warm underside. There's basically no way to easily fix this. The solution lies somewhere in looking at a pedestal system, which, if you look at it as a roof, creates something like a cavity space. So you've got a pedestal pavers on top, you've got an air cavity, and then you've got your waterproofing membrane and your slab. That is probably the pathway I would look at if I was forced to do a wedding cake kind of tiered balcony design.
Very good. Right, and another question I have here. It seems More related, it's a generic question, says, but does anti-condensation work at all? It would seem like it would actually absorb condensation and prevent drying, resulting in mold.
Could you repeat? I missed the first part of
Does
the question.
the anti-condensation layer work at all after all that we heard? I suppose that's the question.
Okay. As in anti-con, as in the
Yes.
we'll just avoid trade names. Let's call it a roofing blanket. So basically, we have fiberglass and a foil below. Does it work? We've had cases where we remove the roofing iron only to find that blanket saturated with water. You see, what happens is that you still have a cold surface on top. You still have high vapor loads underneath. If those vapor loads make their way through crevices, and let's say you didn't tape the roofing blanket perfectly well, the vapor pressure is going to drive it through there. It's not going to be able to escape. Vapor goes in and condenses, so the blanket gets wetter and wetter. So yes, some people think it doesn't work. Some people think it works. It's a difficult question to answer because it depends a lot in terms of the workmanship. And the workmanship is a very difficult one to ensure because it is really hard to tape perfectly on site. If you try to go inside a roof space and try to tape it from underneath, it is really hard to do.
I see. And another question here says this: if the dew point is reached inside a south-facing structure during winter in Victoria and vapor condenses in an airtight structure, will the moisture not remain within the structural zone and cause interstitial mold?
That's a really good question. And this, I think, becomes a bit of a design decision. You put we know that the southern side is going to be worse than, say, an intermediate wall. So let not that southern wall be that of a habitable room. Put the garage there, put the sheds there, design it such that something that we don't have to worry about with interstitial condensation is there. And then we can adopt a different approach because let's say it's a garage, then that southern wall doesn't have to be insulated. We insulate the internal wall. So we still enjoy the benefits of that, but we do not expose the internal wall to the south.
When it's possible, I suppose,
when it's possible.
When site conditions allow.
Oh, yeah. Look, I understand we are dealing with so many things at the same time, but I think if we at least have a strategy that can be something that that covers the aspect of due diligence, that we've looked at a possibility, we propose it. It is not us, but the client that has rejected it, even though we've given all the provisions.
And now there's a few other questions, and I apologize if I won't be able to go through all of them. I'm aware of that, but I feel like I probably have to ask you a question which is more general. Any concern, fundamentally, what is your best advice to architects? When we consider the obviously agrothermal analysis is an area of specialist knowledge like yourself and others, I suppose. And so if you were to recommend architects how to manage these risks, you mentioned about duty of care, of course. What is the best source of advice that you would recommend them to lean on to? Engineers or specialists or themselves?
Yeah. If I could rephrase the question in another way, there have been requests to help design a mold-free or a mold-safe house. I have quite strenuously rejected those invitations because I feel not equipped to answer that. And the reason I feel not equipped is because there has not been enough research around this. I am a big fan of doing physical research, not hydrothermal research, because no matter how good your engine is, if your inputs are wrong, your outputs are wrong. So, and I think that's where we are. We don't have material inputs. You might even have a guess at the vapor permeable membranes because they're broadly class 3 or class 4. Each of this is a big range. We don't even know exactly what is the correct number to put into the software, much less the plasterboard, and even less what is the paint vapor permeability. And changing that could change everything. If you put a high vapor, a low permeance paint, your wall may perform very well, but is that representative of reality? So I think what we need is actually a concerted effort to say that we do not have the solutions start doing the science, start doing the research so we can have the solutions to this. And until we do that, we're just taking a step in the dark and we're making promises that we cannot keep.
So you're making a case for performance-based solutions, at least in the NCC. Is it fair to say?
I am even going one step before that. I think we need the research before we can do a performance solution, because we don't even know whether that meets the performance requirement. And by the way, for condensation management, I have come to the position I think it is impossible to meet the performance solution, which asks you to minimize the impact on the health of occupants. How do you prove that?
Mm-hmm.
Which architect is sufficient for that task?
Okay.
Okay, sorry.
I'm not sure
I
if this is going to be very good news for all the...
on you, Giorgio. It's just that I think that some of these things haven't been well thought through enough. It is a burden nobody can meet. If you say this is what DTS is, then I say, well, if you say that's DTS, that's DTS. If you say this is VM, then there's VM. But if you ask me to have a performance solution to meet the performance requirement around health, how is anybody going to take that position?
Okay, so we'll take your exhortation to do more research in this topic. But I think I'm really thankful for your presentation. In particular, I'm thankful that you have reminded all of us as architects of the duty of care that we have. So ultimately, it's important we continue to exercise that standard of care, like most architects do, of course. And so I thank you again, team. And as I said earlier, this presentation will be available for those who want to come back and look at it again. There's a lot of content, so I do invite you to do so. And please do fill the questionnaire in order to provide evidence of attendance in the next 24 hours. So with that, team, thank you again, and I'll say farewell to everybody for now. See you later. Bye.